In this video, we're going to solve the same circuit again, but instead of using node voltage, we're going to use mesh current. So as our typical mesh current analysis, we write down our meshes here. Now we need to keep in mind that we're doing everything in terms of phasors here. So I'll use the capital I phasor notation, call this I1, call this I2, and call this I3. Now because we have that current source in between loops I1 and I2, we're going to go ahead and have to use a super loop around it. So we're going to go around here. And so for our KVL at the super loop, we will have the following equation. First I see the 1 ohm resistor, so it's going to be 1 times I1. And then I have the inductor, which is just a J, so J I1. Then I'm coming into the 6 angle 0 volt source and the negative side, so minus 6. Again, 6 angle 0, or it's the same as just 6. If it had been something like 6 angle 90, I'd have to put it into 6J or whatever it may be. Continuing on here, we now have 1 times I2 minus I3 equals 0, so that's my first equation. Then I can do my KVL at loop 2. That's going to be 1 times I3 minus I2 plus 1 times I3, and then minus J times I3 equals 0. And then the super loop source equation, right? We have a current going up that's 2 angle 0. Again, 2 angle 0 is the same as just 2. So if it's going up there, that means the current going up minus the current going down, the net current is going to be 2. So here's our system of 3 equations. I can go ahead and write it out a little bit nicer here in maybe standard form. So for the first one, I will have 1 plus j I1, gathering together the terms, plus I2 minus I3 is 6. For the second one, I have no I1s, but I do have a minus I2, and then 1, 2, 2 minus j I3 equals 0. And for the third one, I have a minus I1 plus I2 equals 2. This is our system of equations here. Now we could try doing substitution here, but I noticed that I can easily cancel out the I2 variable twice. So let me give these equations a name, A, B, and C. So if I do A plus B, then what I would get here is 1 plus j I1, I2's cancel, and then plus 2 minus 2j I3 equals 6. And if I add together B and C, I would get the negative I1, I2's cancel out, 2 minus j I3 equals 2 here. So that means in the second equation, I can solve for I1, move it to the right, move the other part to the left. I'd have 2 minus j I3 minus 2. Okay, more clear, this is our arrow here. And so then I can plug this into the first equation. I'd have 1 plus j times the quantity 2 minus j I3 minus 2 plus 2 minus 2j I3 equals 6. Let's go ahead and distribute that in. 1 plus j times 2 minus j. Maybe I'll do this on the side over here, not to clutter that work down there. So let's see, when I distribute this, it's going to be 2 minus j plus 2j is going to be plus j, and then minus j squared is really going to be plus 1. So we're going to have a 3 plus j there. So we're going to have 3 plus j I3 Distributing 2 in, minus 2 minus 2j plus 2 minus 2j I3 equals 6. Gather together the I3 terms. 3 plus 2 is 5. J minus 2j is minus j. Move the other terms to the right side. It looks like it'd be 8 plus 2j. This gives me an I3 of 8 plus 2j over 5 minus j, which I could then find out what I1 is. I1 is 2 minus j times this, 8 plus 2j over 5 minus j minus 2. And I'm going to need I2 here, and I can use maybe this equation. Looks like I2 is equal to 2 plus I1. So that's 2 plus this quantity I just found out. And lastly, the thing I'm looking for is I0, which based on this is going to be I2 minus I3. Let's see here, on this I2, those 2's can cancel out, so I really have 2 minus j times 8 plus 2j times 5 minus j, that's I2, minus my I3, 8 plus 2j over 5 minus j. Now they do have a common factor there, and we can try to simplify it and do our work here, but what I'm going to choose to do is use my calculator. I'm going to plug all of it in, let it do all the hard work for me. So I have 2 minus j times the fraction 8 plus 2j divided by 5 minus j. And I'm going to take that, and then I'm going to subtract the fraction 8 plus 2j divided by 5 minus j. And I'm going to get this number here. Again, this is not perfect in fraction form, but we're going to approximate to decimal. 2.15 minus 0.77j. That gives me my phasor current I0. But I want to find, again, I0 is a function of t, so I need to change it from phasor back into the time domain. And the easiest way to do that is to convert that back into polar coordinates. So what I get here for I0 phasor is a magnitude of 2.29, angle. And so right now I'm writing it, what my calculator says is negative 0.34. That's in terms of radians, and you can leave it like that. Or if you'd rather have things in terms of degree, we can do that as well. And so if we convert that into degree there, we are going to get the following number, 2.2829, angle negative 19.7 degrees, 65, put 0.7 degrees there. And so what that means is we have our answer, I0 of t is 2.29 cosine. We don't know what omega is, so we can just write it as omega t minus 19.7 degrees in terms of amps. So we get the same answer whether we solve it by mesh current or node voltage. You can decide for yourself which method is going to be the best in your mind for solving the problem.